In the last video, we defined the average velocity as a change in position or displacement divided by the time taken, where displacement is the difference between the final position and the initial position. The average velocity can be written as delta x divided by delta t, where delta x is the final position minus the initial position, and delta t is the final time minus the initial time. Now let's plot this equation on a graph and see what it looks like. Consider a graph with time on the horizontal axis and displacement on the vertical axis. In the last video, we saw how Usain Bolt broke the world record for the 100-meter sprint by running that distance in a time of 9.58 seconds. Let's plot this time and displacement on this graph. We'll make the starting position of the race to be at 0 meters and the starting time to be at 0 seconds, while the final position will be at 100 meters and the final time will be at 9.58 seconds. So the change in position is 100 meters and the change in time is 9.58 seconds. Since the average velocity is defined as a change in position divided by the change in time, we can see then that average velocity is a gradient of a straight line that connects the start point and the end point, since the gradient of a line is equal to the rise over the run. Here, the rise is a change in position and the run is a change in time. Now have a go at determining the velocity of the motion for the following graphs. What is the average velocity of the motion described in this graph? What is the average velocity of the motion described in this graph? What is the average velocity of the motion described in this graph? What is the average velocity of the motion described in this graph? In summary, the average velocity for any displacement on a displacement time curve is a gradient of the straight line that joins the starting position and the end position.